right. So on number 17 and 18. All right. We are looking at parallel lines some more. On number 17, they ask angle C is congruent to which of the following angles, select all that apply. So if these two lines are parallel, that's what they told us at the beginning. C, which is down here, is an acute angle, right? So this is an acute angle. Oops. So C is an acute angle. Now, that means all the other acute angles should be congruent to angle C. So F, B, and then also this one down here, not labeled, but F and B are the two that we have as options. So those two are congruent. Again, when we have parallel lines, all the angles have to be either congruent or supplementary. All the acute angles will be congruent to all the acute angles. All the obtuse angles will be congruent to the obtuse angles. And the combination of one acute and one obtuse will have to be supplementary. On number 18, you can use those same facts to solve for y. Now, there are a few steps on this one because in order to solve for y, we actually have to solve for x first. Because we can't set an equation equal with an x value and a y value. And you can only have one variable at a time. So on here, 7x and this 3x plus 36, these are in corresponding positions, so they are congruent. So we're going to start with 7x equals 3x plus 36. Subtract the 3x, we get 4x. All right, divide by 4, and you get 9. Guys, please stop talking. So once you have x, that's not our solution. They want us to find y. So we now have to plug it back in. It doesn't matter which one you plug in for. I'm going to do the 7x. So 7 times 9 is 63. That's for both of these angles. Both be 63. We want y, which is over here. So that's 63. Now we have to find the other angle, which these form a linear pair. So we're going to do 180 minus 63. And that leaves us with 117. Right? So now we have 117 for that angle where y is. We now need to solve for y. So we take the 117 that equals to the 6y plus 9. Subtract off 9, that leaves us with 108. Divide 108 by 6. 6 goes into 10 once. And we have 48. 48 divided by 6 is 8. So we get 18 for y. And that's our final answer. Now, if you notice, look at everything we did in this problem. As we went through, we had the values of 9, 63, 117, and 18.
Stop moving, like pick a side, please. Your head is everywhere.
So all 4 of those values showed up as answers. Again, you have to be very careful when doing a multiple choice test to make sure you're answering the question that's being asked. Because at any point in time, you could have stopped and had an answer. This was the value of x. This was the value of that angle. This was the value of that angle. This was the value of y. So again, make sure you're answering the question that's being asked, because all those answers were there. So it would be easy to stop too early. Questions on either of those before we move on to the next part?
18.
So again, first we set these two equal, we solved for x. We plugged it back in and got that these angles were 63. Once we knew one of those angles, these two had to be supplementary because they're a linear pair. So subtract from 180, and we got 117. And then we set that value equal to 117 and solved for y, which gave us the 18. Yes. Linear pair. So two angles that are adjacent and form a straight line. Easy way of thinking of it. You remember, linear means line. So if the two angles are next to each other and they form a line, they're making a linear pair. We get it? And let's go ahead and clear this. And next one. Number 19. All right, just find AD. Well, what information do we have so far? We have that these lines are perpendicular, we have that these are equidistant. So that's telling us that this line, BD, is a perpendicular bisector of segment CA. So if it's a perpendicular bisector, then that means that D, since it's on a perpendicular bisector, has to be equidistant from the two endpoints. So these two lengths are going to be the same. So set up an equation, 9x equals 8x plus 7. Subtract off the 8x, and that gives us just x. Once we have x, plug it back in, and we can solve for AD. So AD is 9 times 7, which is 63. On 20. Yeah. So the marks that they gave us, we had these two pieces of mark congruent. So B is a bisector and it's perpendicular. So this line is a perpendicular bisector. Any point on a perpendicular bisector is equidistant from the endpoints. So D had to be equidistant to C and A. Yes. Number 20. We have another one where it's kind of similar, but instead of giving us a perpendicular bisector, it's giving us an angle bisector. So they gave us the markings on there to tell us that we have an angle bisector. Then they put point J out there on the angle bisector, which has to be equidistant to the sides of the angle. They put the perpendicular line on there so we knew it was a perpendicular distance. So these two pieces have to be congruent. So again, set them equal and solve. 7x plus 1 equals 8x. Solving for x, bringing 7x over by subtracting it, and x is 1. Once we know that x is 1, we have to find GJ. So plug it back in. GJ, 7 times 1 plus 1. 7 times 1 is 7, plus 1 is 8. That's our answer. Alright, on 21, we have the two triangles are congruent. Which of the following statements are true? So let all that apply. So again, all of the corresponding pieces must be congruent in that statement. So on here, M and S are both at the start of that statement. So those two are congruent. NP's at the end, ST's at the beginning. That one doesn't work. For C, we have PMN. PMN. What's that? PMN. We went last, first, second. UST, last, first, second. So that one also works. Then we have D, we have MPN. MPN, we went first, last, middle. UTS. That's our last, that's not the same. And then finally, NP and US. NP first and last, SU first and last. Those two match up. So the three that work are A, C, and E on that problem. On 22. On 22, we have angle R is congruent to angle T. Angle RSU is congruent to angle TUS. And it says these two triangles are congruent. How? Well, again, we have to match them up in order. So RUS. So we got the one marked this side. Let me mark the last angle, so it's easy to identify. So I'm going 1 mark, 3 marks, 2 marks. So follow that same pattern. 1, 3, 2. TSU. SU. Questions on any of those four? Once you get back. All right. Down at the bottom. On 23, which theorem can you use to prove that the triangles are congruent? So look at what they gave us. They gave us two sides. Well, right away, which one do I know it's not going to be?
It's not gonna be. It's not gonna be D.
Can't be B. That's using two angles in one side. Can't be C. That's doing two angles in one side. So now we're down to one of these two. Well, do I have all three sides? No. Do I have two sides and an angle? Well, I don't have the angle, but the one that's in between the two sides should be congruent because that's a vertical pair. So SAS is the one that works. On number 24, right, we have what additional information do you need to prove that the two triangles are congruent by ASA? Congruence theorem. So again, it's telling us they want us to use ASA. So right now, the pieces we know that are congruent, we have Q and R in the two triangles respectively. And we have the segment at the bottom. So if we're doing angle side angle, well, we need to know we have this angle in this triangle. Let me highlight this one. And I'm using angle side angle. So I have Q in that one. I have to have this angle, the one that looks like a right angle. So QRS has to be congruent to in the other triangle RQP. So that'd be C. Again, one thing that could help is if you wanted to redraw those triangles, you can visualize it a little bit better. Questions there? Alright, so let's take this and redraw those for a second. So if I redrew those, so that I had P, Q, R, and S, R, Q. The parts that we know are congruent right now, we have this angle and this angle, right? This piece is being shared, so that's in both. So right now we have an angle, a side, we need another angle. So this is the other angle that we would need in order for it to be proven by ASA. So same thing over here. This angle, this is our side, this is our other angle. So those are the two that we have to use. So those angles, we do have to use three letters to name them. So we're using QRS and RQP. When they overlap, it does help to draw another diagram. All right, then we got into proofs. All right, so
Are we gonna stop at 25 or no?
we're gonna keep going. Because we're supposed to have up to 50. I'm gonna extend it because I don't see all my classes today. Some of them I see tomorrow. So for you guys, since we only on up to, won't be all the way through to 50 yet. So I'll leave it open for turn-in still today as well, so that you can turn before class tomorrow. So you can take it full credit. It should be up to 50.
Oh, so we're not.
You should, yeah, you should. If you haven't turned
It was due
125,
yesterday.
you should turn that one in already. I said you should start going over that one already.
And I turned in.
Again, I'm supposed to turn it before we go over. But get turned in, when you get turned in, the better. All right, on 25. All right, for this one, we have given a figure show of right a two column proof for these two angles be congruent. So we have some missing pieces. On this figure, they gave us a lot of information. So they gave us EAC, this angle here, is congruent to DEC. DEC. They also gave us ABE, ABC, ABC, we convert to EDC. EEC. And they also told us that BC is converted to BC. Those are all given to us on the diagram. So from those three pieces, we can say these two triangles are congruent because we have two angles and non-included side, that is AAS. Now, once you say the triangles are congruent, you can say any of the other pieces are congruent because of C, E, C, T, C. Now, I'm gonna go ahead and mark the triangle. That's this piece and this piece.
Well, you dead wrong, bro.
And now,
How you gonna throw that out like
somebody else asked, no, you asked that, I think. Right? Yeah, go ahead. All right, item 4. So now, it's the triangle is isosceles. Is the definition of isosceles. So, this triangle in the middle. Again, we could put these in any order, it doesn't actually matter, so, C, A, fine. If you change the order of those three, doesn't matter, it's just one triangle that we're saying is isosceles. But now that this is an isosceles triangle, the angles across from the congruent sides, they have to be congruent because of the converse. Sorry, nope, I lied. Not converse. Isosceles triangle here. Isosceles triangle theorem. So they gave us the sides. We're saying the angles are congruent as isosceles triangle theorem. All right, number 26. This one we're just trying to prove that the triangles are congruent. They gave us some information. So again, any information they gave us, we list as given, which they already have labeled. Now, we also have all the different statements here. We just have to give the reason. So BAC, this angle, is congruent to DCA, this angle. Well, what type of angles are those? Those are alternate interior angles. So alternate interior angle theorem. All right, then we go on to the next one. Well, kind of the same idea. ACD is congruent to CAD. CAD. Again, those are alternate interior angles of those two. So, alternate interior angles theorem. Now, we have two parts marked as congruent. The other piece that we know is congruent is AC is congruent to itself. How do we know that? That's an R. Congruent to itself, it's congruent because of property. Finally, we now have three parts. Once we have three parts, we can say the triangles are congruent because of one of our 5 triangle congruency theorems. On this one, we have 2 angles and a side, so it's ASA. ASA congruency theorem. Any questions on either of those? Right. Go down to the next set. Any erasers?
No.
Oh. Let me go back because there is one that I want to make sure I say something about here. This number 5 over here. This was the one in our textbook that they gave it a different name than usual. So again, I don't know which one it's going to be listed as. So I went with isosceles triangle theorem. The other thing that you could see it as is base angle theorem. So base angle theorem. again, this book switches up on us. So, could be either isosceles triangle theorem or base angle theorem. Either one of those is possible. All right, let's go to 27. All right, on number 27. So this time they gave us some more information. AD is parallel to EC. AD is congruent to EC. So they already have it labeled on there. Great. Shown below are the statements and reasons for the proof. They are not in the correct order. All right. So they want to know which one of these is in the correct order. Now, first.
Oh, sorry.
All right, so you said A. Why do you say A?
Well, because first of all, given is supposed to be curves, and then it goes, and then it went straight to the AAS, when that's supposed to be last.
All right.
And then instead of vertical angles, congruency is second, it would do the alternate.
So
So I don't know if that makes sense, but like, it's supposed to flip.
yeah, so, all right, again, you can approach this many different ways. If you want to put them all in order, that's fine. There are some quick ways to make sure things are in the right spot. So first thing definitely is the given. The given should be first, right? So right away, this one is first in A and B, not so in C or D. The next thing I would have looked at was the last statement. The last statement has to be what we're trying to prove, which is this statement here. So number 4. Well, the only one where that's the last statement is A. So A is the correct one. Alright. If we start with our givens, we would have to find 2 other pieces are congruent. Then we would have to say that the triangles are congruent, and then finally use CPCTC to say other sides are congruent. So A is the correct answer. All right, on 28. Why is the 2 triangles here congruent? So choose the correct answer below. So, what do you think? Anyone want to take a guess at this one?
Wait, which one? For number 28?
Yeah,
Give me 1 second. The answer is B.
the answer is B. All right. So, on here, why are those 2 congruent? So they're saying since these 2 are congruent, and those 2 are congruent, then these 2 have to be congruent. So these 2 are congruent by SSS, these 2 are congruent by sine angle side. But if these 2 are congruent and then these 2 are congruent, the first and the last have to be congruent because of transit property of congruency. So that is, which one said all that again?
B.
B. Any questions there?
Can we go over 29 and 30
Yep.
before we leave?
Yeah, what time do we get here?
Oh, wait.
Oh, 8?
4 minutes.
Check 2.
You've been chilling this whole time. So, you don't really know that. Ain't so, no, once. I'll sit up there. First of all,
On 29, solve for the value of y. So on here, these 2 sides are congruent. If those 2 sides are congruent, the angles across them must also be congruent. So if this is 56, that angle is also 56. So 56 is equal to 5y minus 19. Bring 19 over by adding it. So if we add 19 to that, we are now at
75 equals to
75.
5y. I don't know if that's right.
and divide by 5.
And then you get 15y.
15. And that's our answer. Just wanted y on that one.
Okay.
On 30,
This one I need.
these 2 are remote interior angles. This is our exterior angle. So our exterior angle is equal to our 2 remote interior angles. They also refer to these as our non-adjacent interior angles. So add these 2 together. Again, adding these 2 to equal this one. So 4x and 3x is 7x. Negative 31 and negative 70 is negative 107.
You're being assholes.
5x minus 28. I'm gonna go ahead and bring the 5x over to 2x.
Excuse me.
Yeah.
Why is there 101?
Do that right?
No.
70 and 31. Was 101.
I think you said 107. I think you wrote 101.
I don't know what it said, but it is 101. Sorry about that. Sometimes when I'm writing and talking at the same time, it just comes out wrong. But I wrote what I meant. So 31 plus 70 is 101. Then we had 7x and 5x. We're bringing 5x over, so that's now 2x. Bring the 101 over to the other side, so now we're adding 101 to get rid of it. So 101 added to a negative 28. That's going to be 73, right?
Yeah.
Subtract 5 from both sides.
No, you don't necessarily have to.
Yeah. Well, we could have brought 7 over, but then we end up with a negative 2. So it's a preference. That's which way you want to go. Alright. So now, divide by 3.
Finish it.
That's 6.5.
Oh God, no.
That was the game
Come
one.
up there. My pen. No,
I
no.
want
Where's my pen? Right here. Get my shit. I mean, get my things. Bro, let me see. Bro, let me. Wait, why'd you crumble it? I have to read it. I have to read it.